Hello, hello. And today I have Holographic Principle by Shintaro Fushida-Hardy. And I've been thinking about this puzzle for a while. I noticed it when it first came out. It might be a month ago now, and it just got incredible comments. And I thought, for sure this is going to get featured on CTC or something. So maybe I'll hold off and see. And then it didn't. So I think I get to solve it now, which is pretty exciting. I've been in love with the Shintaro's puzzles for a few months now. I think they're wonderful, and I suspect this will be every bit as good. It's rated 4 stars for difficulty. It has 125 solves, which for a 4-star puzzle is quite a lot of solves, and it still has a 99% rating. So yeah, I'm just very excited to try it. Let's get into the rules. It's a chaos construction. So um, like Sudoku, it's actually a Latin square rule. The digits 1 to 9 are going to be in every row, every column. But instead of every 3 by 3 box, there are going to be 9 regions of 9 cells each. Those regions will be orthogonally connected, but they can be in any shape they want. So this might be a region. And let's say I made this purple. Then I might have another region, 3. That might be another region. And so if I had something like this, that's too close together in color for me, something like that maybe. Then the digits 1 to 9 would appear once each in this region, if this turned out to be a region. And the digits 1 to 9 would be once each in this region as well. So we have the row and column constraints. And instead of 3 by 3 box constraints, we have to figure out where the regions are. They can be anywhere, but they will also have 1 to 9 once each. And then we have these arrows. It's the only other rule in this puzzle. I have these 3 given digits, but then I have these arrows. And I noticed in the description that the constructor was really trying to get something to solve just from what they call boundary conditions, meaning just something at the edge and everything in the middle just kind of gets filled out from there, which I think is quite cool that this works at all. So we'll see. But anyway, the arrows on the edge, what do they say? They say the digit in a cell with arrows is the total number of cells belonging to the same region seen by the arrow in the cell. This includes the cell itself. So there's no example here. I'm just thinking, hold on, entering different regions obstructs this vision. So let's say I had a region that looked like this. It's a normal 3 by 3 box. Well, it's not going to work, but this arrow, and then this did anything else. So maybe I have another region like that. This arrow sees 3 cells in its region. So this would be a 3. And then because it sees itself, and then these 2 arrows, and then this blocks vision. Whereas these cells would both have to be 1, which obviously is not going to work. But if this were the region, because they'd have 2 ones in the region. But if this were the region, the arrow would indicate, 1, it'd be 2, because it sees itself and then 1 more digit before it hits the wall. And then this one, I believe, would be 3, because this arrow, because the cells that are seen are these 3. This one doesn't see any extra. So this would also be a 3. So clearly that's not the region, but I don't know how we're going to do it from here. And maybe slightly more complicatedly, suppose I had a region like this. How many is that? That's 8. Add 1 more. Suppose this were purple, and then I had something like this was blue. This would now be a 1, because even though it, in some sense, there's another purple cell on this diagonal, this region blocks the vision. So this is a 1 here. It can't see this because this blocks vision. So, this also would not work because these would both be 1, but hold on to make sure I don't have, okay. So that's it. Those are the rules. There are very few rules, and supposedly this is all going to solve it. I know it will, because 125 people at least have already solved this. So, so let's give it a go. I'm just going to reset this so I know how long I'm taking. And then where do I start? I'm trying to think between these. So, these cells are either 1 or 2, and they can't both be in the same region because if they were, they would both be 2. So I know that this, so in fact, I know they're both 1. So this, I'm going to call this pink, and I'm going to call this blue. Those are different regions. This is going to be either pink or blue, but I don't know which one. And these are both going to be 1. Because otherwise, I would need to have, yeah, if these were the same region, they would both be 2, which breaks. They can both be 1 because they're in different regions, and they're not in the same column, and they're not in the same row. But that means this is more than 2. So whatever this is, I don't know if it's pink or blue, but whatever this is goes to, like, let's say it's pink. It picks up this, and then it goes down here because this can't be 1. So this has to see down to at least here. The reason I can't do the exact same logic over here is because this arrow has a down arrow as well. So if this were, these could be the same region, and this could be 2, and this could be, say, 3, if these were all in the same region. In fact, that looks quite likely. We'd get 2, 3, 1, and that works out quite nicely. I don't know what this is. I don't know what this is. This seems pretty similar. Okay, let's keep going over here. What is this doing? See, the thing is, when there's 2 arrows, there's really no limit to how high this can go. Well, no, okay, interesting. So I think maybe what I'm supposed to see is that, like, this cell can't be that large, actually. Like, it can't be 9. I was thinking it could be 9, but every cell it sees that is counted towards this digit has to be in the same region. So if I somehow had 1, 2, 3, 4, 5, 6, 7, 8, 9, I mean, first of all, it would take a 9, so that breaks. But even if it didn't, I mean, this cell would have to be in the same region as this cell, which just can't happen because they have to be orthogonally connected. So for every cell in the diagonal, I need a cell in between to connect it. Now here, I think you could actually get to 6. 7, 8. Oh no, you couldn't get to 6. So the best you could do is 5. I think the same thing is going to be true of here. I can't get, like, let's say this is pink. 1, 2, that's 3. I would need to do one of these 2 cells to get here. Let's say I stay going up. One of these 2 to get to here. And so I think the most this could possibly be is 5. And that's also true of this. I think 5 works here. Well, 5 might work like this here. Well, no, 5 could work like this. That's the simplest way for 5 to work. But 5 can definitely work. So these are between 2 and 5. And I think the same thing is going to be true of these, right? It's like, could this be 6? Could I do 1, 2, 3, 4? So if I have 4 in one direction, I need to connect them like that. And that's already 7, 8. I can't get another one because I need 2 more. Yeah, because there's only, in order to have a 6 work, I would need 2 places where I only use 1 cell to connect 2 cells on a diagonal. So I get 1 here in the center, which connects 3 to 1. But I need 1 more. Because any other cell I add, whether it's up or down, needs another one. So I can get 4, I can use 4 cells in the region to get 3 on this digit, 3 on this cell. But if I want to go up again, I've got to add 2 more. So from 4, so if this is 3, right, I can do that using 4 cells, right? To get this up to 4, I need to add 2 more, now we're up to 6. To get this to 5, I need 2 more, and then I'm up to 8. To get to 6, I need 2 more, but that puts us at 10, which doesn't work. So this is at least, this is no more than 5, and this is no more than 5. With the exact same logic, this is even more restricted because I don't get the benefit of this cell doing double duty here. But I can still get to, I can still get to 5 quite naturally. But these are the digits 2, 3, 4, and 5, which means these are the digits 6, 7, 8, 9, which is interesting here, potentially. I think that means this can't be 9, because if this is a 9, I have 2 options. Either I don't go up at all, in which case I go all the way across. But then these cells, then this is the region. These are both 1, which breaks, and these are both 9, which breaks. So this can't go all the way across. So if it's 9, it has to go up at least 1. But if I go up at least 1, then that means this is at least 2, and that means it takes a cell from here. But if this is 9, every cell in the region has to be kind of in this L shape. So that's not a 9. And it can't be, oh no, it could be an 8. It could be an 8 if I do this. That's possible, or this. And I just don't take this. I was going to say this can't be 8 because it would have to take this, and that would break it if this is at least 2. But because that would have 2 cells at least. Oh, no. Actually, you could do this even. Yeah, there are lots of ways this could work with 8. Okay. But so I don't know what's going on there. Okay. So I have, this goes to here. This. And there's got to be something where, like, if this is too big, it's probably going to break one of these. Like, let's say this is 5. Whichever way it goes, doesn't matter if it's purple or blue. Whichever way it goes, it's certainly, well, if this is 5, it can't be pink, because if it's 5, then this blue has to get out. No, actually, that's okay. I'm lying. So it could be pink. But if this is 5, I either go this way or this way. But either way, I take row 2, column 2. And I mean, I take row 2, column 2 either way. But if it's 5, that completes the region, either like this, or some kind of combination of the two. Right. By combination, I mean, these cells along these kind of outer diagonals, I get one, like if this is a pair and this is a pair and this is a pair and this is a pair, I get 1 from each pair going along down if this is 5, which means that this is not part of it. And so this doesn't go up here. But actually that could just be fine, right? This is blue. Like, let's say that's blue. This could just be a 2. And, well, maybe it can't be 2, but it could be 4, right? And then this could get out. And yeah, actually that seems okay. I don't see what's wrong with that. Is there a reason this can't be 5? Well, if this is 5, actually if this is 5, it doesn't take this, because this is part of this. And if this is a 5, it can't get to here, because if this is a 5, let's say it's a 5 that takes this. That means this is all in. And now I've got 4 cells used up. And I still need to add 3 more. I can't get to here because it would pen in pink. So if this goes to here, it would have to take these as well. And there's no way to make that work. There's no way I can get this cell up to here and take both of these. Because if I want to get these 2 in the same region, I have to do it directly. 1, 2, 3, 4, 5, 6, 7. Oh no, you can do it directly. But that means I either take this cell or this cell and not both. So if this is 5, it just goes straight down. I don't think that means anything, because this could be 2. Like, I don't see a problem with this as a region. I was thinking the fact that 5 has to go down means at some point it's going to have to go down. But this could just be not 5. It could be 2. And then this has to be at least 3. This has to go to here. But I mean, that seems perfectly fine. And I just don't take, I could go around like this for 3 more cells. And that seems to work just fine. Maybe this is the reason this can't be 5. I don't see it, if there is. So maybe I have to think about these. I feel like I did a good thing here and found this. And it feels like there should be some kind of conflict here. I just can't see it. Maybe there's a problem with 2s. Like, could this be 2? Let's say it's blue and 2. And all that says it doesn't go to here. But I mean, it could do this. That seems perfectly fine. Maybe I have to think about whether this is blue or pink already. I thought I couldn't figure that out, but maybe that's the next frontier here. Oh, or is it that I can do the same thing here? These are also, I mean, this is 2. Sorry, that's much more straightforward. This is just a 2, because it can't be 1, and it can't be more than 2. So these are the same. So these are all the same region, because if this were not, so these are in the same region by the 2. This has to be there, because if it weren't, it would be hemmed in and it'd be a 1-cell region. So that's like this. This can't be 1, so this is at least 3. So these cells are also here. It can't be 5, because I have these 2 both. So if I want to get to 5, I'd have to do it directly. I'd have no room to take extra cells. So this is 3 or 4. This is not 1, and there's no way it's 5, right? 1, 2. If it's 5, you'd have to take all of these. 1, 2, 3, 4, 5, 6, 7. Oh no, it could be 5. Wow, that somehow works. Oh yeah, because I have 1 extra. Yeah, that makes sense. So this is 3, 4, 5. This doesn't have to be in the region, but is 1, 2, 3, 4, or 5. Right, so these can't be 2 because they're in the same region as this, but this one could be 2 because it's not necessarily in the same region. And this could just be 5 going down like this. Hold on, no, this is at least 3, so this has to take that. Because it's not 1, because it already takes 2. So now I have 6 here. Does that get rid of 5? No, I think not. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 9. That's fine. Is the reason this couldn't be part of it? Maybe this can't be part of it, because if it were, maybe these can't all be 3, 4, 5 for some reason. I mean, if this were part of blue, it couldn't be 1, because it would already take this cell. So if this were part of blue, this would be a 3, 4, 5 triple. And this is 1, 2, 3, 4, 5 as well. Because any cell, any arrow, any cell that only has diagonal arrows can't be more than 5. That is kind of what I think I proved over here. So if this is a 3, 4, 5 triple, so if this is part of blue, this is a 3, 4, 5 triple. That seems plausible. Could this be, well, this is 6 cells. 7, we would need, ooh, no, I might have some problems here actually. Yeah, I would need, yeah, no, that doesn't work, I think. Well, if this is pink, say, not this pink, but a different pink, then how does, oh, no, sorry, other way. If this is blue, and we get a 3, 4, 5 triple here, how does that possibly work? Because I would need to add, I mean, this is already 3. This is 3. This has 3 already. This has 3 already. This only has 2. And none of them are on the same diagonals. So to make this 3, 4, 5, I would have to add, 4 more cells. Just forget the connecting cells. I think you could connect them all pretty handily. I only have, like, these add up to essentially 3, 3, 2 for now, which is 8. but 3, 4, 5 is 12, and none of them on the same path. So I would need to get to, I would need 4 more cells when I already have, oh, I already have 7 even. So yeah, that's not even close. So this is in fact pink. Well, it's something that's not blue, which means it can be 2. But anything it takes is down here. Is there a reason this can't be blue? 1, 2, 3, 4, 5, 6. It would have to be, if it's blue, it does this exactly, and this would be a 1. So no, that doesn't work. So this isn't blue. It could be pink, but this doesn't get over it. So this doesn't get to this, and it's at least 3. So whatever this is, I want to be careful about coloring this because it could be pink, but it might not be pink. I mean, we get orange, which to me means like maybe pink, and it's at least 3. So at least goes to here. I'm guessing pink actually is going to be orange, and that's going to force this to go down here. But we'll see. And now if this is 5, it goes to at least here. Oh, this isn't 2 anymore. This isn't 2 anymore. So this goes to at least here, actually. Which means that this isn't orange. So if this is pink, yeah, this will be blue. Because if this is orange, the only way to make that work is this would have to go like this. Because it certainly couldn't be blue, because then we would hem in pink and it just wouldn't work. So if this is at least 3. So it goes to at least here. It would have to take pink. If it's orange, it has to take pink. And then this would have to connect. I mean, all these 3 interior cells would have to connect, because otherwise they'd be stuck and you couldn't make a 9-cell region out of them. And then these would both be 3, because this is 9 cells. 5, 3, 1 is 9. And then these would both be 3, and we have 2 3s in the row, which doesn't work. Well, in fact, one of these is just a 5. That's interesting. Hold on. One of these is a 5, and these are not the same. But this goes to here. Hold on. Yeah. Yeah, these are not the same. We've established that, because if they were, everything in the interior would have to be in there. This would be 9, these would be 3. That doesn't work. So this is not orange specifically. And this is this, because this is at least 3. So this is not orange. So this is 3. And this is orange to get there. And then this is 4. Oh, this is really nice. Whoops. No 7s. Hold on. But yes, 5s. And then this is 5, which means whatever this, I still don't know if it's pink or blue, but these are all the same, which I'm going to label as, I'm going to call this green for now, and figure out later if green is pink or blue. Now this probably is pink, actually, I'm thinking, because it'd be fairly natural to have like a pink thing, this orange thing, and this blue thing. Wow, okay. Is there a problem with this being 5 now? I think that's well, I have to be careful about counting. Okay, if this is blue, then pink necessarily has to go to orange. Is there a problem with that? 1, 2, 3, 4, 5, 6, 7, 8 to connect, and then 1 more cell. Let's say I did that to be most accommodating to blue. 6, 7, 8, 9. I don't know. Okay, but this now can't be green. Because I already have, yeah, this cell cannot be green because I already have 5 cells here that have to connect directly. So if this were also green, it just wouldn't work, because that would be 6. I could connect these as 7, This could connect 8. This could connect 9. I have one more left over. So this, whatever it is, which could be blue, but it might not be. Like if green is blue, if green is blue, it doesn't have to go. But whatever this does goes to here. So let's call these purple. Now I bet this can't be 5. Well, yeah, this can't be 5 because it would have to go to here. And how is it going to get here directly without being part of green? So this isn't 5. Oh, in fact, sorry, this is a 5. So these are just not 5 by Latin square logic. So this notation is kind of confusing to me. So I'm sure it's confusing to you. So what am I supposed to do next? Is there a reason that this like cuts off too many cells here? No, I think I already tried that. Is there a reason this can't be 5 now? That would add 2 more. I still have 1. I have 1 to play with. That might cause problems. I don't know. It's a little confusing to me how to think through this. This could be purple, right? I mean, this could just be a purple region. 2, 3, no problem. This would be 4, but I think you could do it. I was wondering if this had to take this, because this now is at least 2. So this goes up at least 1 cell. Oh, and this is a 4 now, so this goes to here. That's gonna. Oh, but 5, that worked, maybe. 1, 2, 3, 4, 5, 6, 7. I have 2 more blues. What am I doing here? I don't know. If this, I keep coming back to this can't be 5. Well, this probably can't be 5. Because if this were 5, we'd have that for sure. Like, let's say we did this. Well, that might work actually. Okay, it's got to be something. I didn't want to do this because it seems kind of complicated, but it's got to be something to do with the number of cells I have in this like diamond, this triangle, I mean. Because there are, so how many cells are there in this diamond? There's 9 plus 8 is 17, plus 6 is 23, plus 4 is 27, which is exactly 3 regions. Which is exactly 3 regions. And I know I have at least 3 distinct regions, orange, blue, and green. So this is pink. And I know it doesn't, so yeah. Right, did I do the math right? 9 plus 8 is 17, plus 6 is 23, plus 4 is 27. And 27 is 9 times 3. So, okay, so why did I pick this outline? Is because this is kind of this is the narrowest I could possibly make. Like, this is the most compact I could possibly make the 3 regions, which are now coded as orange, blue, and green. And since that most compact region has 27 cells, it follows that those 27 cells are exactly those three regions. Because if there were, oh no, it doesn't quite follow. It doesn't quite follow because in theory I could extend more and have a fourth region in here. But I can't have a fourth region in any of the spaces here that I have in between. Like I can't, there's no way that any of these cells, these white cells and this pink cell, can be none of green, orange, or blue. I can't fit a new color in here. Because if I fit a new color in here, it could fill up the white space that has adjacent to it, or this pink space. But then it would be stuck. It couldn't go anywhere else. It would have to absorb one of these new colors. So given that that's true, it then follows that these three regions take up exactly those 27 squares, which means this green, the first step has to be, this green doesn't go down to pick up any of these. So this green is in fact pink. So I'm going to make it a pink green rather than vice versa, even though there's more of them. And it doesn't go, so, and further, pink does this exactly. This is the pink region. Now this has to be either, I mean, it can't be pink because pink's done. So it's either orange or blue, but it can't be blue because they have to go through orange. So these are orange. Then how many do I have left in blue? 1, 2, and further, this isn't blue, so this is a 3. Blue doesn't take this, so to connect here, this has to be blue. And now I have 2, 4, 6, 8. So exactly one of these is blue. I don't know which. And these are going to be orange. And one of these is my blue cell. I'm going to draw a border around pink so I know it's done. And that also means purple is blue. And this has to be blue, otherwise it can't get out anywhere. That did a lot, potentially. I mean, it felt important. I think it means this is a 7. So I'm thinking, where does 7 go? Well, what's going on with the 7s up here? Because there's already a 7 in pink. There has to be a 7 in orange and a 7 in blue. And there also have to be 2 7s in these 2 rows. And they have to go in blue and orange here, which means 7 isn't here. It's not here by the arrows. It's not here, but for the same reason not these, or logic, Latin square. It's not here. So this is a 7, which is a digit, a high digit much earlier than I expected to get one. I was wondering if this could be 8 now again, but I think it could. I think this still works with 8 when this is a 1. Could this plausibly be 4? I think maybe. I think it could. Yeah, sorry, I'm stuck again. I guess I can draw a border here as well, if that's helpful. It's just, it feels like there's not enough to go on, but I know there is. I think I know that this digit is here, actually. Do I know that? No, it's one of those. Or, yeah, no. I don't know what it is. Well, this digit is an orange, blue, and this other pink. I should make this something else because these could touch. And I'll finish this so I don't have some straight thought about pink being orange. So what was I thinking of? This digit. This appears 3 times in these 3 colors. And not in row 3 and not in row 5. This one by Latin square / Sudoku. Oops. And this one because of the 7. So, where does this appear in blue? In one of these spaces. Where does it appear in pink? In one of these spaces. And where does it appear in orange? In one of these spaces. Yeah, okay, so it is in one of these 3, but that's not as helpful as I... So if it's here, it's 1 or 5. But it could be here and be 2 or 3. Okay. But I can say the same thing about here, I believe. This digit, which is not this digit, appears in pink, orange, and blue. And is not, because it's not 7. So these 2 digits, which are different, are 2 of these 3 digits. I don't think that's too helpful. Okay. These are going to be resolved by what digits are here. It's the only way to resolve these because the arrow logic is done up here. I still have these. Oh, these aren't 3. Start with easy stuff. This can't be 1. Because if this is a 1, well, that's not true. This could be a 1 if it's not green. I was thinking if this is a 1, this would have to grow to here, but then this would catch it. But these could be different colors. This could just do something like this. And then this could grow out like that. Okay, there's got to be these diagonals. I had to figure out, could this be a 4? I mean, it seems very natural. Yeah, but it also seems plausible to not be 4. And this could be anything. Okay, could this really be 4? Let's do something similar to where we counted cells here. Like, how many cells are in here? There is 7 plus... Oh, but the thing is, this could... Well, let's just count. 7 plus 5 plus 3 plus 1 is 16. So I would need 2 more cells. Which could be those 2. Like 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say that were a group. and this were a group. This would be 2, this would be 3. Yeah, that's fine. I don't see an issue there. I mean, one thing I have to keep in mind is that this cell, which this is clearly not blue, because that, I mean, this, if this were blue, it would, the region would be exactly this, because this would have to connect here and take these 2 cells. It couldn't leave anything on the border out, because if it did, I would have cells that needed to grow to 9 and were surrounded, which doesn't work. So it would have to be exactly those 9 cells. But then this would be a 1, and, which it can't be. So this is not blue. Now this region has to have a 1, but that doesn't mean this has to grow, which has to be in row 3 or later. But that doesn't mean that this region has to grow past it, because this could be a 2, and I could just do something like this. It's very complicated. What am I supposed to do next here? One, 2, 3, 4, 5. Is it plausible that this is not purple? This would be a 6, and it will go all the way up. And then I would have, and then I would have to take at least this cell. It couldn't be blue, so this would have to take another cell like this. And then I would take one of these 2, depending on which of these was the 2 and which was the 3. Which seems ridiculous, but it's not impossible yet. And whichever one it took would be the 1, the digit 1, because it needs a 1 and it wouldn't be there. Yeah, I don't know. Okay. Can I do something with 5s? I'm just thinking, oh, what are 1s? Because I need a 1. Yeah, it's 1s. Neither of these are 1s, but I need a 1 in orange. Oh, I need a 1 in orange. Where's my 1 in orange? It's so simple once you know what the right question is. Where is my 1 in orange? It has to be here, because this is these 2 rows, or 1s are taken. This is the only cell that could possibly be orange and 1, and this is the only cell that could be blue and 1. So those get decided. This is no longer a 1, so this is now green. And it's either 2 or 5, which are very different. We'll come back to that in a second. Actually, no, we'll come back to that now. We're done over there. If this is 5, it's these 5, which means these have to be part of it to avoid cells that can't connect. This is already part of it. And so we get 1 of these. I don't see any issue. I don't see any issue with that. Okay, one of these is 3. Not one of these is 3. Can I see, like, where does green get a 1? I mean, I could, well, I can't get a 1 from here, actually. But I could get a 1 from, say, oh, if green is 5, where does it get a 1? 1, 2, 3, 4, 5. Yeah, yeah, this can't be 5, because then where would green get a 1? That is wild. Because if green is 5, then these are green. These cells, what color are they? The only thing that can be is green to escape. And I've got 1, 2, 3, 4, 5, 6, 7, 8. I need one more. It's got to be one of those two. Even if we call them both green, one is gone from all of these possibilities. So that is wild. So this is in fact a 2, which means this is a new color. Could this be 5? Well, if it's 5, it definitely takes this, which I think is going to mean it's not 5. Because if this is a 5, it can't go 1, 2, 3, 4, 5, because then green would be boxed in by other colors. Because if this is 5, hold on. If this is 5 and not green, start there. If this is 5 and not green, it doesn't take this. It goes to take those 5 cells. But now where does green go? It can't go past this maroon 8, and it can't go past this blockade. So we've blocked green in, and it can't grow to 9. So if this is a 5, it has to be green. And so we'd have these 4 cells plus these 4 cells. These 3 cells. And I need at least 3 cells to connect them all, which gets us to 10, which doesn't work. So that's in fact a 1, which means this cell, which we'll call purple, because it could be maroon, is specifically not green, which means green, in order to grow, has to go out like this, which means purple has to grow out like this. I think it's possible, not here, but like green has to go out a little bit, but like if this were green, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if this were green, could I fit 1, 2, 3, 4, 5, 6, 7, 8, 9? No, it'd be 5, 6, 7, 8, 9. That'd be 11. That's way too big. And if I make this less compact, it just gets worse. So these are in fact different colors. But I don't think that's going to matter too much. Okay. Now I've got 1, 2, 3, 4, 5 ones. Maroon needs a 1. This other maroon needs a 1. Let's call it something. Let's call this yellow. Not next to green you won't. Let's call this orange again, because I'm basically done with orange. I'm gonna draw this little box here to be like, which of these is which? What is this? This is at least 5. But that could easily be purple. But these are all the same. Which I'll call this, no, it's too close to that maroon. Too close in location. I'll call this blue again, and just know that this could very easily be purple. But these are all the same region. Oh, and these are all the same region, which cannot then be blue because that would be 10. So this is a new region, we'll call it red. This is a 1. I mean, the reason this goes to at least here is because these are all at least 5. And these can't be 9, because if they were 9, these are different regions. If these were 9, they would take this, but then this arrow couldn't see. Like if either of these were 9, they would be the entire row. But neither of these rows could be the entire region because of this little blockade here. Because if this takes this cell, it has to take this cell as well, and therefore it can't get this one. This can't be 8, because if it takes this purple, red is blocked off. This could be 8, though. If this is 2. This would be 6, because it couldn't be purple. But I think we established that that's possible. Okay, where are my ones? My three remaining ones are those two cells and no, those three cells and these cells. These are all my one candidates. So but this, I mean, this could take a one from this purple. Where does green get a one? One of these is my green one because green, 1, 2, 3, 4, 5, 6, 7, 8. Oh no, or that. Wow. That would be truly wild. Well, no, because if I did that, orange would get cut off. So it can't be that one. So one of these two is my green one. Can I show that blue is purple? Like, what if blue is not purple? If blue is not purple, it has to go like this, which means this is my green one. 1, 2, 3, 4, 5, 6. Green would have to grow again. 1, 2, 3, 4, 5, 6, 7. Oh, yeah, no, that doesn't work. Blue, okay, well, blue has to be purple. This is hard to see, but you can see it. So if, and I'll suppose blue's not purple. Purple has to grow, right? And green has to grow. But as soon as green, because even if green takes this cell, that's 1, 2, 3, 4, 5, 6 cells. It's got to grow 3 more. That's the 2 that has to grow. Now orange is stuck. So I'll do it this way. Purple is blue. So that's not 1. One of these is my green one. So where does orange get a 1? Orange is going to get a 1 from over here. And there's no way orange is purple. 1, 2, 3, 4, 5, 6, 7, 8, 9. It doesn't work. Orange can't be this dark purple. So the 7 regions, the regions I have are 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the colors. There are no other colors. And this can't be blue. I don't think it can be orange. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it can't be orange either. So this is this purple, which means this is this purple. Which means, what does that mean? This has got to be orange, right? Could this be, there's no way it's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's no way it's that blue. 2, 3, 4, 5, 6, 7. This only has one more cell to go, so it can't be here. There's no way this gets there. So this is orange. Probably I can, because if this is green, orange is cut off. This blue can't get here. This blue can't get here. Maroon can't get there. So this is orange as well. So these ones, one of them is orange and one of them is this maroon. This is at least 2, so that's maroon. So now this is at least 3. So this is 3, 4, 5, because it can't go up to here. And this is now not 8. This is at least 6. So 1, 2, 3, 4, 5, 6. This goes to at least here. This can't be maroon because if it is, we already have 6 cells. I can't take this. If it's this cell, I've got to go directly here to get to 9. But then this becomes a 1, which it can't be. So that's blue. I mean, there's just fairly clearly nothing else this could be. This probably has to be blue. It can't get to maroon. 1, 2, 3. Oh, it could be orange. Yeah, could be orange. Okay. This can't be maroon. So this has to grow. Easy. That's red. And it's got to grow more. Oh, and one of these is a 1. So if red tried to grow up through here, like let's say this is not red. Then for red to grow, 1, 2, 3, 4, 5, 6, 7. I mean, if this is not red, then red is defined exactly like this. But then, oh, that might be okay. Yeah, this might be orange's 1, and this could be maroon's 1. Oh, that could just barely work, I think. I say. This is not 7 anymore, because it's in a region with another 7. One, 2, 3, 4, 5, 6, 7. This can't be 8 anymore. And I think when this grew out, 1, 2, 3, 4, 5, 6, this has to go to here at least. Oops. So now, and now this can't be 5. Oh no, it could, and this could grow out like that. Never mind. That'll be okay. But I bet that would cause some problems. It would cause a problem. So this can't be 5, because if it were 5, then this would be the region. This would end up being a 2, and this would also end up being a 2. So that's not 5, which means this, could it still be orange? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that might still work. Well, hold on. Now let's think about, can this be 4? If this is 4, we've already got 7. Yeah, 8, 9. No, it doesn't work. How do they connect? So that's not 4. I think this can't be 4. 1, 2, 3, 4 is the way it would have to go. Because if it's not blue, it would have to be, I mean, we would break red. Yeah, so it would have to be blue. But now I have 1, 2, 3, 4, 5, 6, 7, 8 in blue. I need to connect it twice, so that doesn't work. So this is not 4 either, which means this is 4, which means blue goes 1, 2, 3, 4. And these cells, what color are they? They have to be blue. 3, 4, 5, 6, 7, 8, 9. And if this is purple, we get 1, 2, 3, 4, 5, 6, 7, 8, 9. And then these are both 2. Does not work. So this is blue, which gives me 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, 1, 2, 3, 4, 5, 6, 7. No. I messed that up. Oh no, down. I broke it. Because this can't be purple and it can't be. Could it be orange? 1, 2, 3, 4, 5, 6. No. Not even close. How does this work as purple? It doesn't. So I must have broken something. I mean, this is already too big. Hold on. Let me back up. Let me back up all the way to here. Why can't this be 4? We have purple, which is 7 digits long. If I take these 2, which I would need to if this is 4, there'd be 2 disconnected in the 9. So that's not 4. If this is 4, well now I can, if this is 4, then these are all blue. Those have to be blue, and then I'm at 10. 2, 3, 4, 5, 6, 7, 8, 9. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. No, that is okay. Right, so what was the problem with this? If this is blue, that finishes blue. And then this is a 2, 3 pair. Sorry, if this is 4, that finishes blue. And then this is now a 2, 3 pair in purple. But that doesn't work because I would already have 1, 2, 3, 4, 5, 6, 7. How come this had to go up? Maybe that was the problem. Oh, it's because this had to grow. But if this is 4, I'm sorry, if this is 4, it can't be not blue because that breaks red. We have 1, 2, 3, 4, 5, 6, 7, 8, and this would cut it off. And it can't be red because there are way too many cells. So this can't be 4 going down here. If it's 4, it's 1, 2, 3, 4. All the same, so they're all blue. These 4 and these 4, 8, 9, can't connect. So this could not be 4 then. This is 4, but now I get a problem with blue, with purple, right? Which is that, I mean, this cannot possibly be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's no way it's anything but maroon, which means I have 8 cells in maroon. I'll get 1 more. This has to grow, but which means maroon is done, but now these are both 2. So I broke it earlier than this. Okay, well, where did that come from? From this has to grow. Where did I get that that's purple? So do I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, this is one of the colors. It's not blue. So it's purple, and that's purple. And purple has to grow. No, this runs into the exact same problem. So maybe it's further back. So what did I, hold on. Why does that become purple? It's the exact same logic I just said. So what is wrong with that logic? What's wrong with that logic is this can be red. Oh, it's not blue. This can't be blue, but it could still be red. Okay, so I'm not going to logic that this therefore must be red because that's too much to look ahead. I made a mistake. So what am I supposed to find here? Well, what I'm supposed to find is that this is definitely not red. Because if this, so let's ignore this color for a second. This is definitely not red. Because if it were red, it would be 9. And it's not blue, and it's not this blue, and it's not anything else. So this is a new color, which I will call maroon. And that is not red. So 1, 2, 3, 4, 5. So at least goes to here. And this has to grow. So that is definitely maroon. And now I can say that this cell, this is the one that's going to be 4. If this is 4, oh, but now without those 2 there, that actually could be 4. If this is 4, well, actually that could work now too. No, hold on. If this is 4, so I now do have the 9 colors. And I think these 2 had to be orange for the exact same logic as before. Because the only other plausible thing this could be is green, but that would cut off orange from growing to 9 cells. Okay. So if this is a 4, if it takes these 4, it has to be part of purple. So it would look like, which doesn't work. And if it's those cells as part of blue, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it can't connect here. So this is not 4. But now I think either of these could be 4. Well, can I use, if this is 4, we get 8 here. This definitely becomes purple. Then I have 1, 2, 3, 4, 5, 6 in purple. I have 3 more to grow. This would have to grow. One of these would grow. Yeah, I think that could just work though now. Now that I don't have those 2 cells in there. Okay. Red has to grow, which means this now has to be 1, 2, 3, 4. So this is purple or maroon. Is there any way this is blue? Yeah. This could be blue fairly easily. Okay. Is there any way this is not maroon? If this is not maroon, then this is a 2. Oh, it could be orange, I think, probably. Yeah, this could just be orange. If this is blue, I don't think so. Where is blue's extra cell is maybe interesting. There's only 1 more cell in blue. If this is blue, that's going to cut green off. 1, 2, 3, 4, 5, 6, 7, 8. So that doesn't work. Blue can't grow there. Blue could grow here, and green could take all of these and be okay. Blue could grow here, and green could still grow out like this. And orange would still be okay. Could this be 8? Could this really be 8? 1, 2, 3, 4, 5, 6, 7, 8. No. And then I would have to take these. So that's not 8. Could it be 7? Maybe I should think, could this take this at all? If this takes this, we only get 2 more cells, one of which has to be a 1 from this row, from this column rather. No, but it doesn't immediately break. I know it will break eventually, but that's too much look ahead. So what am I supposed to see here? What this cell? Is there any way this is not blue? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. That does break blue. So if this is purple, it has to go there somewhat directly. In fact, it has to go there directly somehow. But the most room I can give blue still only leaves at 8 cells. So this isn't maroon. Could it be orange? And then this is a 2, which doesn't take this. No, okay, yeah. So this can't be orange either, because we'd have to do that to get to orange, which means this is a 2, which means this is a 3. Oh, but this could all be blue. No. Because if this is orange, this is orange, because we can't cut that off, which means this is not 4, which means this is 4, which breaks it. So this can't be orange. This is definitely blue. Can I do something similar here? Yeah. If this is orange, now the problem is this one I think could be maroon. This isn't orange, but it could be maroon or blue. Because the problem with it being orange is, to be orange, I have to kind of come out to get to orange, which means this cell is not blue. But this cell is also not maroon. So this is not 4, and this is not 4. And we have no 4 in the column. So this is blue or maroon, but I don't know which one. It depends on if this is 4 or this is 4. The thing is, even with my breaking look ahead before, I don't know which it is. I don't know which is correct. Can I use something with accounting? Like if this is 4, 5, 6, 7, 8, 9, say, or 8, 9, say, that leaves 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that works okay. And this would be 2, 3. Yeah, that works. In fact, I think that's probably right. Okay, can this be 4? If this is 4, we end up with exactly this pattern. Plus 1 more. What's my plus 1 more? I don't know, but what I do know is that these would become 2 and 3. And these would both be purple, because I only get 1 more. 3, 4, 5, 6, 7. I get 2 more cells to play with. One of them is the 1. Oh. Well, actually, it would mean that. So in the world, it's hard to explain, so let me just draw it out. In the world where this is 4 and these are all blue, these become purple, maroon, and I've got 7 cells here. Now, one of these cells, and one of these is a 3. So either this is 3, in which case I pick up a 1 here, or this is 3 and I pick up a 1 here. But it would have to be this way. Sorry, it couldn't be this way. Because if it's this way, these 3 cells need to get allocated to blue and maroon. Because if this is maroon, these would be isolated if they weren't part of those groups. But I have now 19 cells for those 2 groups. So that doesn't work. It would have to be here. But actually, I think this is okay. I think this is a possible 3, 2. Yeah. But what I'm seeing there, I mean, this is probably too much look ahead, but what I'm seeing is that this can't be 2. Because if this is 2, this is 3, this is 4, and we end up with that problem where 2, 3, 4, these cells are kind of, we have 3 cells to go in here. I'm going to use it. I don't, because it doesn't do much, so I'm just going to put it in there. But so this is actually purple. I'm going to see if that lets me do something. Yeah, they're kind of 2 states of the world. One where this is 4. That's 7. And we get, I guess I would know at least how many of these 2 cells get taken up. Because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So one of these cells will be purple and one will be blue. And then one of these cells will be purple. These would have to be red. Well, and now can I say that this is definitely red? I probably can. Because if this is purple, so I have 1, 2, 3, 4, 5, 6. At least one of these 2 to connect. And if this is purple, so is this and this. Then I now have 10 cells. So this is at least red. Because it can't be blue or orange either. Oh, could it be orange? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, that would cut off red. It wouldn't get big enough. Maybe, I think an easier way to see this is, suppose this is not red. Oh, but I can go over here in that case. Yeah, so you have to do that. But this is in fact red, so this is not 6. This is probably not 7 now, right? 1, 2, 3, 4, 7, 8. That's 5. Yeah. So this is, if it grows to here, that's 6. Otherwise, it's 5. If it grows any of these places, This is a 5. This could be blue. I was wondering if this had to be orange. I don't think it can be purple. Because then, if it's purple, this has to be blue. But in the world where this is blue, this is blue. So this isn't purple. It's not this blue. It could be... I think it could be blue like that. 1, 2, 3, 4, 5, 6, 7. Oh, no. It can't be blue like that because then I have too many cells over here for purple. So this can't be blue or purple because of a kind of total cell. So like this is 9, 17. I see. So there's only one more cell possible. This is great for this. There's only one more cell possible that I can add to this group. That's because these cells are definitely all blue or maroon. So I only get one more cell, and this is 17 cells. So I only get one more cell to add to this clump to get to 18, which is 2 times 9, which is the number of cells in both of these combined. So, and these two are together, which means they're not this clump. They're not orange, because that's 9. Can't get a 10. So these are in fact red. That is in fact an 8, and that is in fact a 2. And this becomes a 6 and makes both of these. There we go. Now, which means this is purple. What is that? 1, 2. These are not 6 anymore. We get 6, 7, 8, 9. So now we're done. This is blue. Oops. In fact, these are all blue. This is not 4, so this is. This is now 2. This is now 3. This is my 1, which means this is my 1, which is green. And then this is my 1, which is orange somehow. So orange has to go through like this. This is not blue, so it's orange. These have to be orange as well. So we have 2, 4, 5, 6, 7, 8, 9. So this is green, and then I just don't know between these two which is green and which is blue. Wow. So, okay, so we're almost, now we have to, so I'm well into the Sudoku. This feels 5 stars to me, but that's just not my strong suit, I guess. And now I've just finished the coloring. Almost, I mean, I have 2 unknown pairs. And now I have to do an irregular Sudoku with these givens. This is a 5. Okay, let's start with, ones are done. All right, let's just go number by number. 2s. I need a 2 in orange and a 2 in pink. Well, the 2 in orange is one of these. So those aren't. So one of these is a 2. My orange and pink. I need an orange and blue, which is one of these. Oh, no. It could be one of these. I need a 2 in blue, which is one of these, because these 2 take up this spot. So that's not 2, that's 2. I need more. Oh, that's obvious. Orange is now looking hard. One of these. So my orange and blue 2s. Maybe I should change this color. Is there a color I haven't used? I guess it's yellow, but yellow's pretty close to green. Oh, it's not too bad actually. Or what if I made this one yellow? Oops. That could be better. Okay, so now my blue 2 and my orange 2 take up those 2 spots, and then my, or here. And then my, I have 2 oranges as well. Wait, so I'm missing a different color. It's other purple. Yeah, so let's call this one other purple. It's okay, whatever. I've got lines there. Ones are done, right? Twos, I've got pretty much marked. Threes. Oh, I thought I had more threes than that. Ooh. Okay, no. So now my blue 3 is whichever one of these is 3. Because I have two threes looking into this L shape, which means my 2 that's blue cannot be that either of those cells, because my 2 that's blue, like whichever of these cells is blue is 3. So my 2 that's blue is down here, which means that's not 2, and that is. I really like that. That's neat. And then how about 3s again in orange? Is one of these two, which means that's not 3, which means that's my 3, which is blue, and that is green. And we're now done with that flip. That's not 2. That's not 2. I guess moving on. 4s. Not a lot to go on with 4s. Oh, except that I do know my 4 in purple is there, which means my 4 in pink is here. Which means my 4 in maroon is here. Which means my 4, oh, it could be either of those. I was going to say my 4 in, where's my 4 in column 3? Had to be in orange, but that's not true. I get a 4 here. Oh, I get a 4 here. So I do get, well, it's not what I thought. My 4 is there. My 4 in column 3. Could only go here. That might be all I can do on 4s for now. Let's try 5. Oh, nothing on 5s. Actually, these purple digits are becoming very, very constrained very quickly. Get a 5 here. Like my 2, 4, and 5 in purple are in these 4 cells. I don't know if I can do more than that. Oh, these are 7, 8, 9. So this is a 4, 5 pair. Which means my 5 in yellow is one of those 2 spots. These are 3, 6, 8, 9. 9 is not either of these. So this is 3 or 6 only, this particular cell. These are also 3. Oh, this is 6, 8, 9. These 2. Okay, let's, do I have more 7? I don't have a ton of 7s to go on. This could be 7, otherwise I could say my light blue 7 is one of those. I get 8 here, actually. So this is not 8. 8 in green is almost interestingly limited, but it is not. 8 in yellow, though, is one of these two, which means that's not 8. So my 8 is one of, that's worth highlighting, I think. This is a 6. It's very obvious. Okay, 3, 6, 8. There we go. That did something. I just had to do the obvious one. Where does 6 go there? And then 3, 5, 6, 7, 8. What are these? Not 3. These are not 8. Hold on. Is this a 5, 6 pair? I think it is. I don't see anything that conflicts with either of those. This could be 3. Oh, no, it can't be 3. Where does... Oh, this is 3. Well, so it's that 3 at least. So what am I... What's the digit? 4. 4, 5, 6. 4, 4. Oh, yeah. No, I don't know anything about 4s. Okay. I need a 3 in here. Oh, yeah, where does 3 go in this row? Only here. Do I have my 3s now? One, two, where's my 3? That's one of those. 2. 1, 2, 3, 4, 5, 6, 7. Yeah, so these are my 3s now. 5, 6, 7, 8. Oh, not 8. That's just a 7. That's a 6-8 pair, so that's a 5. That's an 8. I get, what do I get? These are all from 6, 7, 9. 2, 4, 5, 7, 8. 2, 4, 5. Why is this not a 5? Because it has to be there. So this is 7 or 8 only. Where's my 8 in blue? I guess it could be either of these. Okay, I just know what these digits are. These are 2, 4, 8, 9. And I can probably get rid of some 2s, which means these are 6 and 7, which means this is 9, which means this is 7 and this is 6. 1, 2, 3, 4, 5, 7, 8. One, 2, 3, 4, 5, 6, 9. 6. I feel like I'm so close, and yet, what? So whichever. Oh no, these could all be. This could be 2, 4, 5. This could be 6, 7, 9, all purple, and then this would be light blue. Yeah, no, it's too much. So hold on. What are these 3 cells? These are 5, 6, 9, which means, yeah, so 7 and 8. And the other blue that's here is also 7. And so, okay, so now where is 8 in blue? It's here. And then my light blue cell here is 7, which means that's not 7. These 3 cells are 5, 7, 8. That's not 7. That's not 7. That's a 7. Am I done? Am I 1, 2, 3, 4, 5? What am I missing on 7s? I need a 7 here. I need a 7. Well, this is a 7, 8 pair. Ah. Whoops. Four, 5, 8, 9. No, 8's seeing here. 8 makes this 9. 8 makes this 5. I should know this digit is a 6. This has a 5 in the region. This will be 4 as well. What is this? This is a 9. Oops. Not 4. Not 4. Not 8. So 2, 9 pair here. This has an 8 here, so that's the 4. Oh, no. Oh, no. How far back did that mistake go? Okay. Hold on, I already had an 8. Trying to rush. Okay, so that's not 5, 7, 8. It's 5, 7, 9. Sorry. But still, these weren't 7 because my blue 7 is here. So that's 7 still. This is not 8. This is not 7. It's easier when you can just make up numbers. Well, this is a 4 or 5 pair. So these are from 6. This is 6 or 9. This is 7 or 8. This is a 7, 8 pair still. Okay, all that logic still holds. I say all that, but then oh no, it goes, yeah, and it continues on. So all that logic actually was good. I just needed to have a 9 here instead of an 8, I think. This one had an 8. 4, 8, 5, 9, 2, 9. This is not a 9. This is not a 9. That must be a 9 then. Okay, sorry. Allergy attack averted. This is 2, 4, 5, 7 in some order. I can probably do something with 7s. 1, 2, 3, 4, 5, 6. Where are my 7 pairs? One is here and one is here. I guess that's worth marking. 8 should be done, right? Yeah, 9's. No, I have 1 9 left, which is here. I see 9, 7, which means that's 7, which means that's my blue. That's therefore purple, which is actually not the way I wanted it to go, but I don't think it matters too much. Because once I had the 7, actually, that had to be 2, 4, 5. 2 and 5 makes this 4. This is 5, 6, so this is 2, 5. Is that really right? I'm going to get rid of this green and check it out. Wow. Yeah, really good puzzle. Really beautiful puzzle. I did not do it justice. I mean, I think I definitely did some too much look ahead right here. There's probably a more elegant path there, but it was probably something close to what I found down here. I don't think that helped that much. Anyway, wonderful puzzle. Thank you for setting it. And if you managed to watch through some of that, thank you for watching. And I will see you again next time.